Now we're going to switch over to division. Now, once again, we're going to try to relate this back to fractions. So, again, a side-by-side set of problems. And the nice thing is we're teaching both of these at once because division's really not that hard. Once you understand multiplication, division's actually easy because you learned a trick a long time ago that to do division, the easiest way is actually to change it to a multiplication problem. So like this problem right here, the very first thing I'm going to do is I don't want to do the division. I'm going to actually do multiplication. And the way I do that is I'm going to recopy the first fraction. I'm going to change division to multiplication, but in order to counteract that change and end up with the same answer, I'm going to change this second fraction to its reciprocal. I'm going to flip it. And so we get this. And so now it becomes just like the problems in the last sets of videos. It's just a multiplication problem where I factor and solve. Now the same thing applies to these more complicated rational expressions. If it's a division problem, then we're not going to deal with the division. What we're going to do is we're going to use that shortcut and change it to a multiplication problem. So here we got the first rational expression left alone. But then we're going to change division to multiplication, and we're going to flip this to its reciprocal. So now both of these are just like all the other problems in the previous videos, and now we can just break things into factors, so we can then cross out any common factors. So here, 5 and 15, well, 5 is a prime number. I'm going to leave it alone. 15 will break up into 5 times 3. Now I could break up 4 into 2 times 2, but I'm thinking 12 has a 4 in it. So the greatest common factor here is 4, not 2. So I can pretty much make this 4 times 3, and I'll just leave this 4 alone. There's no need to break it up into 2 times 2. Because now I can cross out the 4s, cross out the 5s. I don't cross out the 3s because they're both on top in the numerator, and they need to be across from top to bottom. So we just get 9. Alright, so let's do the same thing over here. Now once again, we've already gone through the process of changing the division problem into multiplication, so now it's just a matter of factoring. Here, if I look at this combination of numbers, especially the 7 and the 10, this would break up into a times a for a squared. And then what would multiply to 10 but add up to 7 would be 2 and 5. 2 times 5 is 10. 2a and 5a would give us 7a. Oops. Alright, now let's take a look here. A minus 6. When I look at that, none of our factoring tricks apply. It's kind of like the 5 over here. It's kind of like a prime number. So the best we can do is just recopy it and put it in parentheses so we can consider it its own factor. Over here, this looks like the difference of squares shortcut. A plus 6 times a minus 6. And then finally on the bottom here, this won't factor, so we'll just recopy, just like we did with the a minus 6. Alright, so now I can go through, and just like with this problem, now that everything's multiplication and broken up into factors, I'm allowed to cross things out. So here I see a minus 6, a minus 6. Here we've got a plus 5 and a plus 5. And I think we're good to go. So here I get my answer of a plus 2 times a plus 6. And once again, if the exercises you're doing say leave it in factored form, you can leave your answer like this. If not, then go the step further and multiply it all back together again. A times a squared, 2a, and a times 6 is 6a, so 2a and 6a is 8a, and then 2 times 6 is 12. Okay, so depending on which problems you're doing, if it tells you to leave it in factored form, you would stop right here. If not, simplify it all the way by multiplying it out and leave it as a trinomial, a squared plus 8a plus 12.